Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we will try to get to as many questions as we can near the end of today's webinar. Also happening at the end of today's webinar, we'll be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Infrastructure as Code, 3 critical concepts to get security right. Our speakers today are Avner Germano, who is the VP of Product Marketing at Lacework, and he's being joined by Scott Ford, Principal Architect at Lacework. Gentlemen, thank you so much for joining me today, and I will put myself on mute and let you get right to your presentation.
Good afternoon, everyone. This is Avner Germano with Lacework, and we are super excited to have everybody here today. So just a couple of little housekeeping bits. There is a Q&A tab on your system and a chat tab. Feel free to drop stuff in there. We will pay attention to that as we go along. And today I'm super excited to have Scott Ford talk to you about infrastructure issues and, more importantly, security considerations of when you're using infrastructure as code. Infrastructure as code is just an amazing technology for those of us who've been around for a while and watched administrators of infrastructure go from manual changes to really being systematic about how you make changes to infrastructure, and the way that infrastructure as code and all the practices around it have increased the reliability of systems, the scalability of systems, has just been incredibly impressive to watch. One of the things that's super interesting to us here at Lacework is how does security fit into all that? What are the cultural changes that you have to make? What are the process changes that you have to make? And so to talk about that today, we have Scott Ford. Scott has been prior to Lacework, was a distinguished architect at Chef. Prior to that, he ran all sorts of different systems, and he's basically been automating things for a very long time. And so he's spent a lot of time not only automating large infrastructures, but also building the products that help others automate. And here at Lacework, he has really helped us interact with a number of different partners and other tools that are used by high-performing software teams. And in that, he's been able to talk to lots of customers about what they do. And so today we get to hear his reflections of that. So with that, Scott, why don't I hand it over to you?
Thanks so much, Avner. Hello, everybody. Thanks very much for joining today. Again, this is Infrastructure as Code, 3 critical concepts to get security right. As Avner said, infrastructure as code, it's a hot topic. This isn't new. It's been a hot topic for quite some time. Even so, I have to say that I was not expecting the response that we've got for this talk. Given the fact that Lacework is not an infrastructure as code product, and furthermore, it'd be totally fair for you all to be saying, what does Lacework even know about infrastructure as code, and who is this dude that they've got talking about it? So it's a fair question, and it's something let's go ahead and we can just take care of right away. As Avner said, I'm Scott Ford. I'm the Principal Architect for Technology Alliances here at Lacework. I'm based out of the San Francisco Bay Area. My team and I, we're responsible for building open source tooling and integrations with the Lacework security platform. Our goal is really to make it easy for our customers to automate their workflows around Lacework. The overall goal is allow teams to operate at hyperspeed without sacrificing security. So why am I here to talk to you about infrastructure as code? I mean, quite simply, this is because the last 14 years, I've been working on large-scale automation, infrastructure as code projects. Additionally, as Abner also said, the last 6 years before joining Lacework, I had the opportunity, I call it a privilege, of working alongside brilliant colleagues in the broader community at Chef Software. I got to work with companies around the world to really help them think about how they transform their businesses through automation. And those experiences that I got, they literally just changed my tech DNA. It still informs the way that I look at the business world today. I'm a staunch believer that businesses that want to compete and thrive today, they need to change their culture. They need to leverage software, automation, and data in order to innovate and bring value to their customers. So this isn't just some lip service that I'm paying here. It's something that I very much practice today. I practice what I preach. Most of my experiences out there have been working alongside production engineers, developers, cloud engineers, DevOps, if you will. But at the same time, I also got a lot of opportunity to work with security teams, and that continues to even more so today with just being that Lacework is a security platform. So it's undeniable that there's massive shifts going on within companies that are operating in the cloud. And security experts, even if they're not the ones writing the infrastructure automation, this infrastructure as code, they have a huge role to play. And so today what I'm going to do is I'm going to dive into 3 critical areas to focus on to get security right with infrastructure as code. But before I do, I think it's important, I'm not going to make any assumptions whether you are an expert or if you're new to infrastructure as code, but it's important for us to answer the question, the big question, which is, so what? Why should I even care about any of this infrastructure as code in the first place? And to answer that question, I think it's important to take a look at the market and what's going on out there in the world. Last month, early June, I did another webinar. It was titled Shifting Left, Taking the Blocking Out of Security. And in that talk, I shared this data from Meritech Capital that we had been discussing internally at Lacework. The article was published in late May, and it reported on public SaaS company valuations that they were at an all-time high despite the global pandemic. And seeing companies adopt SaaS is starting to feel like the norm now, but honestly, it wasn't that long ago that many businesses were reluctant to depend on SaaS products. And now companies large and small are really changing their tune. They're really changing their strategy. And it's not just that they're changing their strategy that they are going to start depending on SaaS products to help move their businesses, but many businesses are also on a tear to build their own SaaS products to grow their business. And this particular report from early May, it covered 29 companies whose quarter ended on March 31st. And as I sat down to work on this webinar that we're going to go through today, I remembered about this, of course, and popped over to Meritech Capital and found out that they had updated their findings. And the data in this article was released on July 1st, so just the beginning of this month, and it surveyed 49 public SaaS companies. And of those companies, 47 of the 49, they beat their consensus estimates, showing that these companies aren't just surviving during the global pandemic, but they're absolutely thriving out there. So thinking about this list of companies that are in this article, show me a CEO that wouldn't love to replicate those successes right now, right? Who out there that's on this webinar, if you're, maybe you're working at one of these companies, but if you're not, and you're working at a company that's trying to operate like this, wouldn't you want to be a part of that? I mean, these companies, they operate at a high level to deliver their products to market. And I know this because I've had the opportunity to work with a number of these companies, both as a consultant in my previous role, But now a number of these companies are also, we're proud to call them customers of Lacework. So it's fair to say that many of these companies, not all of them, but many of these companies are what you would call elite performers when it comes to delivering their products to market. And when it comes to tools and processes, and more importantly, to the culture they follow, their methods are no secret. Data from the annual State of DevOps report shows that these elite performers, they focus on automation and continuous delivery and are shipping more frequently, and those changes are getting to customers faster than their competition. When changes fail, they recover faster, and they also see lower change failure rates. And those numbers accumulate, and the elite performers continue to outcompete the slower moving competitors. There are many attributes that elite performers have in common, but one thing is for certain, and that is automation is literally, it's just fundamental to the way that they operate. Infrastructure as code, it's simply a way to automate your systems by declaring the state of your infrastructure with software. Think about it as instructions to configure a system or a cloud resource, and instead of a human being logging into a server or logging into a cloud console, you write the desired configuration with software, and the software ensures that those resources are configured exactly as you specified. There's many players in the space, and I have no intention of wading into a religious war of which tool to use. Some of the tools you see in front of you are far better suited for automating different resources than others. One thing is for certain, and this is from my own experience, is that it's far more important that you understand the systems, you understand the infrastructure, you understand the APIs you're looking to automate than it is to choose the right tool. My own background, as I mentioned, is in Chef, but I've also used Puppet and Ansible, AWS CloudFormation. To this day, I still write a ton of Terraform code. And all these tools, they follow a similar paradigm, and that is to think about code on the left and systems on the right. You may have heard another term that's thrown around often, which is cattle versus pets. When done right, we don't have to worry about logging into systems. We look for where the automation code is stored to make the changes that we need to make. So speaking of storing infrastructure as code, another thing from my own experience in working with these companies to automate their environments is I found I could teach the basics of infrastructure as code in an afternoon. But it was when we would pivot from learning to real world implementation, and I would inevitably ask the question of my customers, what do you use for source control? Source control. And way more often than I'd like to admit, the customer would say, source what? And that leads me to the first critical concept for the day, which is to get your priorities in order. So Git. If you're new to infrastructure as code, or you know that teams are using infrastructure as code internally at your companies, and you want to learn how to collaborate with them, then you need to understand that Git is the foundation for any successful and also secure implementation of infrastructure as code. Git, of course, is the source control tool of choice these days. It's used by over 90% of the companies out there. The product itself was created by Linus Torvalds, who created the Linux kernel, and he designed it to solve the specific challenge of distributed software development, having software developers contributing to the Linux project from around the world. Now, I don't suspect that he had any notion that we'd be in a global pandemic 15 years after its creation, but Git, as a distributed source control tool, is literally built for the type of work that we're all doing today. It's remote, distributed, and hopefully, most importantly, collaborative. That being said, Git itself does not provide any real security. For that, you really need to adopt one of the Git services, such as GitHub or GitLab or Bitbucket. This is also fundamental in the software world. But for sysadmins, security engineers, compliance officers, GitHub is not the first place that their minds go when they think about how to operate securely in the new world. But honestly, they should, because these platforms, they bring a ton of benefit when it comes to security. Some of the major benefits that come with adopting these platforms is, first and foremost, access control, right? Deciding who has the ability to read your code, who has the ability to make changes to the code that configures your environments. You've got auditing and compliance, right? So you always want to have a record of who made what changes, who approved those changes. And these are something that these services capture as well. You've got cryptographically signed changes. This is super important. My team, we deal with open source software. We have open source projects up on GitHub. We're willing to take pull requests from people. We always want to know that the person who signs those commits is actually the person he or she says they are. So this is also something that these services can provide. Now, another thing is we can configure our repos using these services to enforce things like code reviews on all changes as a way to implement segregation of duties. This is something that states that changes must be approved by someone other than the author of those changes. And it's also something that's required for a lot of the regulatory frameworks that we're all trying to adhere to. This is by no means an exhaustive list of all the security, but just give you a sense when thinking about this. If your mind is not like, you know, we got to start looking at Git as the foundation for security for these projects, then you really should. So in securing automation code is critical, because in many cases it literally runs our businesses. Configuring fleets of servers, containers, or cloud resources can be done in just a few lines of code. Even single attributes in infrastructure as code could be the difference between exposing your customer's data in something like a cloud storage bucket or keeping it protected. But storing automation code in Git and running automation code are two very different topics, which brings us to our second critical point in getting security right with infrastructure as code. And that is establishing a one-way to production. If you were to sit down right now and think about your environments at the companies that you're working with, think about all the ways that change happens to your systems, to your infrastructure, to your cloud resources, to your containers, to your applications. What would you come up with? I'm willing to bet it might include a list that looks something like this, right? We've got cloud console access as a way to make change in our environments. This is where it all begins, right? This is where it usually starts on our journey, is we go into AWS, we create ourselves an account, we get ourselves set up, we start adding team members, we start giving access to these through the UI. It exists in GCP, it exists in Azure. This, of course, while it's the place it starts, we oftentimes hang on to this as a method for us to be able to deploy changes into our environments. But it's fraught with peril from a security standpoint. The reason being is that when you make changes in the UI, it's manual. There's no error checking. There's no peer review. It's just you and a few clicks away from a security disaster. There's API access, right? All of the major cloud platforms have a robust application programming interface, or APIs. This allows you to interact directly with the cloud services once authenticated with a set of API keys. These APIs are actually also what the infrastructure as code tools use to integrate as well. And while you can tightly control access to those APIs, many developers at our company, you have full access to make whatever changes you desire, right? And so again, assume good intent, but it's also without visibility, you can lose sight of how change is happening out there. And of course, there's just human beings, right? Human beings, we're writing code, and we have this access, and we have this powerful infrastructure as code automation that we're working on, and we just execute it. We just execute it manually. We execute it from our laptops. We execute it from a shared server, a Bastion host, right? And you might be sitting there saying, no ways, man. People don't do that anymore. Nobody executes automation code manually against environments. No. Of course they don't, right? Of course they don't. They never do that, but they do until they do, right? 2017, an AWS engineer, an authorized AWS engineer in the change, made a mistake, a term we call fat finger to command. And instead of taking a few servers offline, this person took a larger pool of servers offline that powered AWS S3. And not just those systems, but those systems were also the systems that monitored AWS S3. And if you think about all of us and how the applications that we're building in the cloud that depend on AWS S3, with that, it just spiraled into a massive outage. It literally broke the internet. And I don't mean to sit here as like, hindsight's 2020. I've been there. I've been there as a systems administrator. I can remember making a change to an F5 server back in one of my previous roles, and it was about 10 seconds later when I heard somebody go, what just happened to the site? And I just felt those beads of sweat go down. So like, we've all been there, but this can happen. We still do it today. And I know that internally, it's whether in development, whether you're trying to just get something out quickly in production, that people are still making changes manually in their environments. But there are other ways, right? This brings us to another path to change, and that's, of course, the use of continuous integration and continuous delivery pipelines, or just CI/CD. This whole concept that's built on the learnings from post-World War II Japan, auto manufacturing. In software development, it's simply a standard set of steps to move a change from a developer's laptop to production, right? It's when done poorly, CI/CD pipelines can end up looking like some crazy Rube Goldberg chaos machine. But when done right, they're as simple or as complex as they need to be. They're elegant and brings with it speed, efficiency, but also many security benefits. So this idea around infrastructure as code plus source control plus a one-way to production, it wasn't always in vogue. It wasn't. There were plenty of teams out there that were saying, I don't need to do all that sort of software development stuff. I'm just a sysad. I can just write this code and I can execute it. But the industry's really shifted, and actually out of the way that we're embracing this use of thinking infrastructure as code is just another form of software development, source control, pipelines. It's launched a new movement for modern, born-in-the-cloud companies, and that movement is simply titled GitOps. And GitOps it's the basic idea that you store your infrastructure code in Git, and you have that be the foundation for change within your organization. Alexis Richards, he's the founder and CEO of Weaveworks, and he's largely credited for coining the term GitOps. There's lots of, if you Google it, there's lots of different definitions. If we were to follow some of their core principles over there, it's that the entire system can be described declaratively, right? So think infrastructure as code. That the source of truth, or the canonical source of truth for your desired state, is versioned somewhere in Git. Approved changes to desired state are automatically applied to the system, right? So heading through pipelines, and those get applied out. And also that you have continuous visibility to ensure correctness and alert on divergence. So if, for example, in our world here at Lacework, our customers, they get continuous compliance assessments of their cloud environments. And when Lacework finds a resource, such as, again, an S3 bucket, for instance, that has been inadvertently provisioned with public read or write access when it shouldn't, our customers are alerted, and rather than logging into the web console to manually make changes, our customers that have adopted this GitOps mindset, they go to the GitHub repo that has the Terraform code that configures that bucket. They make the changes there. Someone else reviews those changes. And then once accepted, the pipeline executes the Terraform code to remediate the issues. All of this is logged. It's completely auditable. In some cases, there's full test-driven development. But this pattern doesn't just apply to public clouds. Any SaaS product or platform with an API can be automated through that same process. Take GitHub, for instance. If you're on board with what we were talking about earlier, that you should use infrastructure as code to automate your environments, and that securing that process starts with securing GitHub, don't you want an automated process for managing the creation and configuration of those repos? Of course you do. Of course you do. Terraform has a huge library of custom resources for managing many of the different platforms, including GitHub. This is something that's in practice internally at Lacework, and from that, we reap all the security benefits that we've been talking about. We have a single source of truth for how our repos are configured. We have both public and private repos, and those two types of repos may have different types of configuration. We codify that. We enforce the best practices to ensure that all repos are secure at the time that they're created. We have an audit trail for how repos are created and changed, which helps with our own regulatory compliance as we adhere to SOC 2 Type 2 compliance. So if I need a new repo created, I simply open a pull request against our Git repo with the Terraform code that manages our GitHub. Once our production engineering team reviews the changes and approves, Terraform executes the changes and it goes and configures Git. We've also adopted this for our own customers and how we think about our own platform. And it applies to the Lacework security platform because we are just a set of large, robust APIs. Last month, we announced the release of our Terraform provider for Lacework, and that allows our customers to automate the configuration of their Lacework tenants. Tenants being that Lacework is a multi-tenant platform. Our customers can have multiple environments to manage and view the security data for each of their environments independently. And this is extremely important because our customers are operating at massive, massive scale. Most are not securing a single cloud environment, but in some cases, they're securing literally hundreds of them. And adopting this GitOps one-way to production philosophy allows them to have a standard way that they secure their environments with Lacework so they can get back to focusing on delivering their own products to market at hyperspeed. Unfortunately, though, securing your infrastructure as code and storing it in source control and having a standard process for shipping that code is not the end of the story. It is definitely a huge leap forward, but it doesn't account for the most critical concept in all of this, in all of like, how do we operate securely? And that is collaboration. Our organizations are a diverse set of people with a diverse set of backgrounds and experiences. Just because you know about software development doesn't mean that you know about infrastructure. Just because you know about infrastructure doesn't mean you know about compliance regulations. For that, you need to embrace the next critical concept to get security right in these infrastructure as code projects. And that is to break down the silos. To break down the silos and to focus on collaboration. Lacework, the company, we were founded on the premise that cloud breaks security. We were founded on the premise that modern cloud security is a big data problem to solve. And what we mean by that is that the traditional approach of securing environments off of rules that allow or deny traffic based off of IPs and ports, it falls over in a world where environments are ephemeral or we're instead relying on APIs. This screenshot is a 1 hour period of time in one of our small Kubernetes environments as seen in the console. I bring this up to illustrate an example of complexity we are dealing with. And again, this is just a small environment compared to the scale our customers are operating at. So if you're a security engineer that comes from a traditional background of writing firewall rules, and you see something like this, where do you even begin? If you're a traditional security engineer and your background is not Kubernetes and microservices, you're going to have to walk across the aisle, well, it's the virtual aisle these days, and start a dialogue with a colleague that does understand that complexity. At the same time, if you're a developer responsible for building containers free of vulnerabilities, and your security team comes in to tell you that, hey, we've just bought this new platform like Lacework that has a container vulnerability assessment for build time and runtime, and all you need to do is log into another UI to get the data to understand if you're vulnerable or not, are you going to be happy about that? If your world is GitOps and pipelines and someone tells you to add a manual step to an otherwise automated process, a manual step to log into another UI, are you going to do that? So what then? For security to start looking to block developers, are you going to do that? Are you going to look for ways to block to make your environments more secure? Those patterns, they've existed for an eternity in technology. Are you going to look to find ways to bring those old patterns into the new? That has not been a winning strategy in any of the automation projects that I've been a part of. But what has been encouraging, though, is something my colleagues and I are seeing with customers that we are working, and that is a change in culture around the role of security. Having access to a platform like Lacework at its heart, which is a massively scalable data platform, is really helping our security teams bridge the gap with developers, production engineers, with data. The change is that is also going on out there in the industry is to see security as an enabler rather than a blocker. The folks over at Netflix have been talking about this for quite some time as well. This term of guardrails, not gates, is being used by a lot of our customers. And the concept being that organizations set up a process for change that focuses on speed. It focuses on the product, but it does so in a way without sacrificing security. And one way to do that is to provide software teams with relevant security data that they need to automate. All of this is rooted in a unflinching focus on collaboration rather than operating in silos. Now, another area of caution. This is something that I'm very passionate about. My team members are probably going to start laughing when I talk about this, but I'm always on a rant. Another area that we're seeing a shift, though, that I think is really relevant in this idea of infrastructure as code, especially if you're not the one writing it, is, and this is something I think we could do an entire topic on, an entire webinar on, is this concept of auto-remediation. Auto-remediation being the idea that if something is not in line with a policy, then the system can just change it back. On paper, this sounds like a great idea, and absolutely, it can work. But if you're a security engineer and you're looking to buy a capability from a security tool that will just change things in production without collaborating with your developers or production engineering teams, then heed my advice. Be very, very aware So the idea here is not to focus on auto-remediation. It's to get back and just focus on the right word, which is focus on automation. When you've built a workflow, one that like we described around GitOps, when you have a consistent automation in your infrastructure as code that can change configuration in a safe and repeatable way, then and only then can you start to talk about how you have built workflows that auto-remediate. Again, just be wary of tools that offer the capability out of the box without understanding how changes happen within your environment. So if you're a security and you want to keep developers shipping fast, but provide those guardrails, then you really need to focus on collaborating, focus on bridging the gap by providing the relevant security data to the place that developers need it. Over the last 6 months, we've been on a tear at Lacework. We've been working on building out integrations with many of the major CI/CD pipeline technologies that exist today. You know, Jenkins, Circle CI, Azure DevOps, GitHub Actions, GitLab, on and on. If you don't see one of the technologies that you're interested in, chances are it's already on the roadmap for us, but if not, we'd love to hear from you as well. So this is something we're really excited, and we think it's really a path to success for our security and developer teams that want to collaborate together. And again, technology is the easy part. If you want to write from infrastructure as code, it's easy. It's easy to get going. You could start today, and you could start learning how to write some Chef or some Terraform or some Ansible. My guess is, though, if you're looking at infrastructure as code, the goal is how do you help your businesses move fast? How do you help them move in a way that's more efficient than manual processes? How do you help your businesses move in a way that's more secure? If you want to operate a secure, fully automated, elite performing business in the modern cloud, then you have to do the hard part. And that is you have to collaborate and build a coalition of cross-functional teams. The best ones, the best teams that I've ever seen embrace this completely. They've focused on the culture part, and it can't be overstated. So again, security, compliance, developers, operations, on and on, they all need to be represented in a successful and secure infrastructure as code implementation. So with that, I want to close this and say that in the modern cloud, automation is fundamental. Infrastructure as code, it's really just everything is code. Everything is code. So you may be in a company that's moving away from IaC, but again, in API-driven world, we want to automate everything. And so we have to just start thinking in this mindset of everything as code and everything moving in this efficient and also secure manner. But if you want to also then operate securely in this move to automation, then again, we have to consider these three critical concepts. First concept, Git. Get your priorities in order. Git is the foundation for any secure infrastructure as code implementation. It comes with it so many benefits. If your mind is not there already, you really should start thinking about it. It's the place where your developers, where oftentimes your production engineers are starting change within your environments. So even if you're not going to be the one making changes in there, there's plenty of different ways for you to collaborate. Could be adding documentation or adding comments to particular changes. You could be an approver. So get your priorities in order. Start to learn some Git and use that as the foundation for change. Second critical concept, again, standardize as much as you can on a single one-way to production. Call it DevOps, call it GitOps. I don't care what you call it, but just think about that. Standardizing on a one-way to production comes with it so many security benefits. Again, this visibility into the way that change happens. You can add in any kinds of monitoring. You can add in approvals. You can add in automated workflows that trigger the right people to get involved based off of automated tests that run. Again, automated tests as well. So there's just so much that can be that we can take benefits from by having a standard one-way to production using pipelines. And finally, of course, this is the hard part. The hardest part of all is to break down those silos and start collaborating with your teams. Collaboration is the key for any of these successful automation projects. And security folks, you've got experience out there. Compliance officers, you've got experience out there. That's all relevant. And the only way that we're going to get this right is by all of us collaborating together to make these automation projects work. And with that, I just want to say thank you very much for joining up. We intentionally left a bunch of time open for questions, and I'm happy to stay on and answer questions to the team. I think, I'm not sure, Abner or Amy, or
hey,
were
Scott.
You going to
Yep.
take? Yeah.
Yeah, so we've got a couple questions already, and you have other questions, pop them into the little Q&A box in your On24 system, or whatever we call this thing, and we'll take a look and pass them on to Scott. So first question is from David. He's asking, he says, okay, so on things like putting in place automated checks on the Terraform templates or other templates, like how do you suggest going about like even having that conversation with the security teams who are still learning versus infrastructure teams who may be fairly savvy?
So how do you go about talking about, so this is a great question around automated testing. So I didn't spend a lot of time on automated testing today, but there have been some great developments out there in the infrastructure as code communities. There are new frameworks out that exist for validating your infrastructure as code, Terraform code, from the standpoint of functionality, but also now we're seeing a big shift in testing the security configuration as code. Again, the most important thing to do is to just start. Don't get hung up on writing all of the tests. It's very easy, and I've seen this happen many times, that companies fall into this analysis paralysis. The reason I chose to start on the one-way to production is because it's the foundation. You don't start by going, we're going to write all the tests, and once we feel that we've got all the tests together, then we're going to go and start using the pipeline or get the pipeline stood up. You always start with the pipeline first, and then you add in the tests, and you keep working iteratively. And so one of these things that we have to think about in this conversation too is priorities. You can't understand priorities unless you get that coalition. If you don't have your compliance, the people that own compliance at your company, if you're having to adhere to these frameworks, PCI, SOC 2, HIPAA, whatever it is, if they're not at the table for you, how do you know which tests to write? So again, my suggestion in any of these things around test-driven development is start by getting the pipeline in place to have a standard way that the change flows out, and then get a coalition going where you start to understand the priorities of the company and iteratively work across the environment. This is something that's in flight at Lacework. We're always working to improve our tests inside of the products that we ship to market, and we will continue to do that as well. So hopefully that answers your question.
I think so. That's good. So the next one, I laughed when I saw this, but Heather wants to know how to explain infrastructure as code to compliance.
How to explain infrastructure as code to compliance?
Yeah.
Well, I think this is something that's really important, and you know, there early on in infrastructure as code, there was the notion that the configuration code was compliance, that was the, you know, you could just point your auditors at your Chef code or your Puppet code or your Ansible code and go, that's it, we're compliant. See, it says so over there. But compliance and configuration are not the same thing. And it's super important for you to understand that you do have to have a way to validate and continuously prove that your resources are compliant, that they're configured compliant in a compliant fashion, separate from the thing that is actually changing them. So when you have that conversation, again, there's a number of great test frameworks that exist out there in the market. There's the Inspect testing framework, there's Chekhov for Terraform, but they are two different things. There is absolutely the thing that changes it and the thing that proves that it is compliant.
Yeah, that's the code on the code on the left and the system on the right, right?
That's right, and we touched on that as well, Abner, in when we were talking about GitOps. Again, there's multiple definitions of GitOps that exist out there, but the ones from the folks at Weaveworks who were credited with coining the term, the fourth principle is that we have monitoring in place that alerts us when things fall out of compliance. So you may have, as what we're calling, something that may auto-remediate or runs on a schedule and changes things when they fall out of compliance, but you also have to know, too, when things are not in compliance to be notified about it. So having those types of checks in place is extremely important.
Awesome. Let's see. Okay, I think, so this is the last question that I have. If you have another question, now's the time to drop into the Q&A. So the last question comes from a different Scott who asks, when you're looking at the at finding problems with the monitoring, how do you identify where which automation created the problem?
That's a great question.
And we have a similar question, which is, how can you best prevent engineers from manually changing infrastructure directly in the console or using CLI? Which is kind of a similar question, right? Like, how it's sort of there's two sides of that.
Yeah, these are great questions, and there is no easy answer for that. So looking at resources that exist in the cloud and making, and understanding which automation created or changed a particular resource is the assumption that it was automation at all. And back to the point about the ways that change happens inside your environments, there's just because something was created with, say, Terraform, doesn't mean that it was also updated with Terraform. You can, if you've got API access with API keys from your laptop, or you've got access to the console and you can change things there, it doesn't matter where it was created. So again, this is why, it doesn't, to really understand how you prevent people from changing or how you understand where change happened, only happens with a culture of collaboration. We talk about the shared security model. It's such a used, almost overused term these days, but it is true. The only way that we can really make this work within our organizations is if we all get on the same page, and that we, I was talking with a colleague of mine on my team, and we were talking about the ability to get access to Lacework's production environment. And my colleague was like, I don't want it. I don't want any access to Lacework's production environment. I just want access to the code repo, so I can understand what's going on out there on the right. And that's really a mindset. I think that if we want to get better at this and we want to have a better understanding of how changes happen and prevent developers, is that developers too have to say, I don't want that access. I don't want access in the GUI. I want access to Git. I want to have access to be able to make changes. I want to have access to the monitoring tools that ensures that those changes I'm making are happening. I want to have sane ways to test these changes in development. That's really what we have to put our focus on. And that's the place that I've seen this work really well.
Awesome. So the next question, we got a few more that came in while we were asking that. Oh, we got even more. Here we go. How do you avoid single point of failure and God mode access situation within your IaC deployment scheme?
How do you avoid single point of failure? I'm not sure that if I understand this question correctly, is that like a single point of failure in the systems that are executing your infrastructure as code, or in the systems that infrastructure as code are configuring?
I think I think he's talking about God mode access situation with your deployment scheme.
God mode access. I'm sorry. I'm not totally sure I understand this question. But God mode access in your deployment.
So I'm gonna, if you ask that question, maybe you want to provide an example, and we'll come back to that.
I mean, one thing that does come to mind, Abner, is
actually,
that
so here's a similar question, which is, what's your opinion about read and write access to all code repos within an engineering org? Do all developers need read and write access to all code to support transparency and collaboration?
My opinion has always been that developers we all should have read access. If you're hired by a company, and it's not just developers. If I'm in operations, if our sales engineering team wants to be able to see the code inside of our developers' repositories, why shouldn't they be able to read it? If we've got concerns about secrets that are in there, then we've got another problem to deal with, for instance. The part that's the most critical to put in place, and what we touched on around having an automated process for how repos are configured, is to make sure that nobody has the ability to both make changes, and to review and merge their own changes onto a repo. That's the place that I'm absolutely adamant about, that developers should not have, nor should they want, the ability to merge their own changes. You should always practice the 4I rule. Somebody else reviews your changes before they're merged. But as far as read access, bring it on. I think we all get better. Just because if you're not a developer, doesn't mean you don't have opinions or can't provide constructive feedback. So we should always be looking for ways that we can take outside input from teams. But I do want to touch on something, because the idea about God mode is something that's interesting to me, Abner, because there is also gaining momentum, this idea around least privilege. And if we think about pipelines themselves, each individual pipeline is responsible for some service or some infrastructure as code in this case. All right, it might be managing a pool of cloud resources that's out there. Well, what we can do there is we can ensure that the pipeline is configured in such a way that it only has the ability to change those very specific resources. I touched on this in the API access section of this. We can create API keys with least privilege, and that's one way that I think that we can avoid having God mode in our changes. Standardize on the way that change happens, have a pipeline that executes that code, but the pipeline is configured in such a way that all it can do is configure the very specific resources that it's working with.
Awesome. I think we'll cut it. So the one last question, and then we'll call it a day, is when converting to infrastructure as code, what would you suggest as an absolute first step?
when converting to infrastructure as code, what is the absolute first step? The absolute first step is, past learning, learning the actual tool itself is my experience is to try to find some sort of a Phoenix project. And what I mean by Phoenix project is the book, The Phoenix Project. The reason I cite that is because trying to write a bunch of infrastructure as code that, say, manages resources that were already deployed is much more challenging than it is to start with a greenfield environment where you can start from scratch and build it out. So what would be great if you're new to infrastructure as code, past learning it, understand these fundamentals around source control and having a sane way that those changes move out, is pick a Phoenix project that you can collaborate with your team members on and build something from the ground up.
Awesome. So we're going to cut it there, and because we're at the top of the hour, and beyond that, thank you so much for all of your questions, for listening today. We look forward to working with you on making your projects more secure. And so if you have more questions, if you want to use Lacework tools to improve the security of your cloud infrastructures, come see us at lacework.com. And thanks so much for joining us today. Thank you, Scott, for a great conversation.
Thanks, everybody, for joining up. I really appreciate it.
All right, guys, thanks, Scott. Thanks, Abner. Good stuff. Wanted to just real quick remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinar. Webinars and look in the on-demand section, and it should be right there waiting for you. Also want to let the audience know that if we didn't get to your question during the question and answer period, the folks at Lacework are getting a copy of all of the questions, so I am sure that they will be more than happy to follow up with you offline. Okay, real quick before we log off, I do want to do the drawing for the 4 $25 Amazon gift cards. So without further ado, let's go ahead and get to that now. Our first winner today is Alex T. Congratulations, Alex. Our second winner today is Jonas L. Congratulations, Jonas. Third winner today is Ken C. Congratulations, Ken. And our final winner today is, let's see, Natalia C. Congratulations, Natalia. We'll be following up with all of you offline via email to get your gift card over to you. So check your inbox. If it's not in your inbox, please check your spam filter. All right, with that, again, I do want to thank Scott and Abner for a great presentation. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.